Welcome to week 1 of distance learning. I miss all you guys. Hope you are doing okay at home. Definitely feel free to call the school if you have any questions, and I'm going to share a WhatsApp number that you can reach me at hopefully by tomorrow, so I'll make sure to add that to the video. So first of all, you should have all gotten a sheet that looks just like this. It tells you what you need to do. Dr. Sturm's stuff is on here too. So my stuff is towards the bottom. So I'll talk about health in a separate video or towards the end. But first of all, here is science and math. So you'll notice that for most of my assignments this week, science and math go together. I tried to make things easy for you guys so you weren't doing separate assignments and tried to make them stuff that were a little bit more hands-on or interesting. A couple of the assignments you're going to have to give a try because I haven't tried them out yet, but definitely ask if you have questions and hopefully this video will help you too. So first of all, for your first assignment for Wednesday, you're going to, for science, need to finish any stations. So if you have any packets that you need to finish and you have them with you and you're able to do them at home, go ahead and finish those. If you need a packet and it's one you can do at home, like vocab or the vectors one, let me know. Send me a message or call school and I will add that to your packet for next week. Otherwise, you should just review the PowerPoint that I'm going to post on Google Classroom and that I'm also going to go through right now. So first of all, let's go here. First of all, here is a PowerPoint of what you should have learned, hopefully, from our lecture and from those online or those different stations that we did. So what we learned about was motion in one dimension. We're going to add 2 dimensions as we go along. That's not. So motion in one dimension. So hopefully you all know, or were here, if you were here the day that we talked about scalars versus vectors. So scalar has magnitude and a vector has magnitude and direction. In case you don't remember what magnitude is any like quantity or amount that you can measure. So if you can measure something with a ruler, with a speedometer, if you can put it in a measuring cup, that is magnitude. So how can you represent vectors? You can represent them by drawing arrows. A lot of you have been doing that. So the pointy end, if you draw an arrow, the pointy end, aka this end, is the head. And let me rewrite that. It's the head. And the not pointy end is the tail. So make sure that you always add a pointy end. I've noticed a couple people that have just been drawing their arrows like this or like this. The reason why we have a pointy end is it tells us which direction. So when we're drawing that, it's not a vector if we don't have direction. So if you draw it without the pointy end, it's not a vector anymore. It's just a line that doesn't tell us where we're going, right? So we need that to tell us north, south, east, or west, or right or left, or whatever. So make sure to add the pointy end. The other thing that you hopefully should have learned is that you can add arrows together. So make sure when you're adding your arrows, you have one arrow going one direction, and it tells you to add a separate arrow. You're drawing another arrow. Always do. So you have tail, head. At the head of the first arrow is where you're going to start the second one, and so on. So it should always be like that. You should never draw them like this or like this, because then they don't add together correctly. So you need to make sure to move your arrow. So the correct way to draw in this scenario would be to add them together like this to show overall where they went. Yeah, so don't do those. However, there is one time where you may draw arrows that go tail to tail and head to head, and that's when you draw the resultant. So that one shows the overall change. So your delta, right? If you remember from vocab, the delta, the overall change, by showing that you started here. So here's our start size or distance or displacement, etc. Here's our end over here. Just like if you're walking down the street, you start at your house, you ended at the school, you're going to show overall where you went. by cutting out all of your little side trips and just showing start to finish. So that's the only time you can draw a tail to tail and head to head, is when you draw that resultant arrow. So distance to displacement, you guys had that reading, you did the color by number. So distance is how much ground something is covered. So think about your odometer in your car. It is tracking every single little mile you ever drive, even if it's just to back up, to go forward, just to drive around the block. It doesn't care where you started and ended. It's just showing every mile you ever drive in your life. Displacement shows your change, so that delta, change in position. We usually use X for position. So displacement is your change between where something started and where something ended. So if you wake up in the morning in your bed and you fall asleep at the end of the day in that same bed, we don't care about everything you did in the middle of the day, whether you went and rode your bike or came to school or whatever. We just care about your change in position. So where you start, where you ended. So your change in position in that case would be 0 because you started and ended in the same place. Speed versus velocity. So speed is how fast something is going, and it's scalar because it's just a number amount. So 55 miles per hour being sample. Velocity would be a vector quantity because we add a direction to that. So 55 miles per hour to the north. And then acceleration is going to be change in velocity over your change in time, over a certain amount of time. So because velocity is a vector quantity, that means that acceleration is 2. So just to make your heads hurt a little bit, deceleration is really just acceleration, but in the negative direction. So if you did the moving man one with the guy, and he walked either towards the house or the tree, if you put in a negative acceleration, he would slow down, right? So there's a couple things I want to just add to this real quick that are going to help you for your assignments later in the week. First of all, velocity. You can find velocity by doing the change in distance, or the distance, which we usually do distance as a d, over time. And time is usually a t. You can also write that change in x over t. You might see it that way too in the future. And then acceleration, you can find your acceleration by, we usually do A for acceleration, doing change in velocity, V for velocity, not vector. Make sure you get those two straight, over the change in time, or over T for time. So if you see those kinds of letters, those usually go together. S is usually speed. So that's if we don't have a direction, then you might see speed. So you will see that on that first assignment. So that is the video going over what you should have learned in your stations. All right, so here's your first math assignment. So this is the only one that doesn't go with science. This one might be a little confusing. I wanted to try something to give you a real world application that you could do at home. So it will probably involve a little bit of problem solving, but if you have questions, please ask. I'm only grading this one on effort and that you tried. So if you can't make it work out, don't panic. Just try your best, and we'll go over it together, and maybe try to figure it out together either when we get back or over the phone when I check in. So for this one, you're going on a scavenger hunt. So you're going to work through each step. So you just follow the directions, go through each step. So step 1, you need to go around your house or your property or whatever, find something that requires you to either mix 2 things, or it tells you like give this per that. So maybe an example I've used a couple times for a couple of people in class is antifreeze. If you guys ever buy antifreeze that's not diluted for your trucks or your vehicles, you'll notice that it tells you that it should be 50-50. So half of it should be antifreeze and half of it should be water. You can't just put concentrated antifreeze in your car because it'll wreck it. Another one that I think about a lot is, I know a couple of you have livestock, but if you ever have to deworm your animals or even your cats, some types of dewormer that you buy in the bottle will be a whole bunch. And so the one I found was this cow worming medicine called Panicure. So step 2, once you have your item that you found, and maybe you can look one up online if you can't find one around at home, or you can use a recipe is like definitely a very good example, like a baking recipe. So now you need to read what the instructions tell you. So you should write that down here in this section. So for example, if I read the back of the bottle that say instructions or directions, it will say give 1 cc of Panacur or medicine for every 5 pounds of body weight. Now this, I don't know, is necessarily for cows. This is definitely for sheep, goats, and dogs. But that's what I would write. It's just the instructions straight from the bottle, the instructions straight from the recipe, mix. Like on my pancake mix at home, it tells me to mix 1 cup of pancake mix for 2/3 cup of water. So I would write that much, like 1 cup mix per 2/3 cups water. It's 2:0. Now, hopefully your handwriting is better than mine on the computer. Step 3, decide how you're going to use your item. So you need to pick something that you're going to do. I think this is probably the one that's might be the most confusing for you guys. So for example, you're trying to figure out, the goal is to try to figure out how much you're going to need total. So like for my Panacur example, if I have a cow that weighs 2,000 pounds, that's what I'm trying to figure out is how much Panacur, how much medicine do I have to give my 2,000 pound cow? If you're baking, then maybe you're going to say, how many people am I going to bake for? So like for the pancakes, if you look on the back of the box, it usually gives you a couple that they already do for you where it says 1 cup of mix with 2/3 cups of water makes about 7 pancakes. So let's say I want to make pancakes to feed 30 people and I want to give them 2 pancakes each. So I'd want to make 60 pancakes. So how much would I need to make total? 60 pancakes. Right. And then for step 4, try to see if you can make your own equation to figure out your new proportion. Usually the word per means divide, and for usually means multiply. So if you see that, it's kind of like a word problem. If you aren't sure how to write your equation, but you think you can figure out how to solve the answer, then don't worry, don't get hung up on this step. Just go figure it out, see if you can figure out how much to make, maybe ask your folks and see if they can tell you how to figure it out. Because it's definitely valuable to see how other people figure it out without writing down the math all the time. I will say when I do these medication type ones, I have written it down this way in the past where I do 1 cc meds, and since it said per, that's divided by 5 pounds over, and then what I'm trying to find is how much meds, right? This X on top over 2,000 pounds per cow. So then I would solve that. So 1 divided by 5 is 0.2 equals X over 2,000. And hopefully if you've been doing 2 steps equations, you know that to cancel something, you need to do the opposite function, right? So here I would need to multiply by 2,000 and then also multiply the other side by 2,000. So 0.2 times 2,000 should be about 400 cc's. That's a lot. That's probably why we only use Panacur for dogs and not for cows, as far as I know, or maybe there's a different dosage. But you could do the same thing with your pancakes. Would be maybe a little harder to set up, but just reason logic through it. See if you can figure it out. And if you have questions, feel free to call me and we'll work through it together.